On problem number 4, you can see we're given a graph of a function f, and we're given a function g to be defined as 2x plus the integral from 0 to x of f of t dt. Now you notice how we're given a graph of a function f, but the questions are asking us about the values of a function g and g prime. So whenever we're given the graph of one function, and we're asked questions about another function that's not shown in the graph, we should make a little legend to keep our thoughts straight. So we'll start by writing down g of x as it's defined. G of x is 2x plus the integral from 0 to x of f of t dt. Now, if we're going to talk about g prime, we need to take the derivative of the left side, and we need to take the derivative of the right side. So that'll give us 2 plus f of x. Remember the fundamental theorem of calculus, version 2.0. Now to get g prime prime, we need to take the derivative of the left side again, and we'll take the derivative of the right side again. And this legend will be used to help us keep our thoughts straight when answering problems and questions about g. So let's get started. In part A, we're asked to find three values. G of negative 3, we're asked to find g prime of x, and we're asked to find g prime of negative 3. So start by finding g prime of 3. The way this function is defined, this is going to be 2 times negative 3 plus the integral from 0 to negative 3 of f of t dt. Notice something here. From 0 to negative 3, we're integrating from the right side to the left side of the interval along the x-axis. That's backwards from what we're used to doing. So keep that in mind. So 2 times negative 3, that's negative 6. And now we're going to add this integral. Well, let's take a look at the graph. The integral is represented as the area bound by the quarter circle in the x-axis. This circle has a radius of 3. So the area of the circle would be pi times 3 squared, which is 9 pi. And we have a fourth of a circle, a quarter of a circle. So we're going to say that that area is 9/4 times pi. Okay. Now, if we were to integrate f of t dt from negative 3 to 0, we would get 9/4 pi. But remember, we're integrating from 0 to negative 3. And do we all remember what happens when you reverse the limits of integration? That's right. We get the opposite answer. So our integral is really negative 9/4 pi. So instead of plus and negative, we're going to come back down here and call this negative 6 minus 9/4 pi. And that is it. We just found the value of g prime of, we found the value of g of negative 3. Now we need to find the value of g prime of x. Well, we already found that in our legend. G prime of x is 2 plus f of x. And now we need to find the value of g prime of negative 3. So this is going to be 2 plus f of negative 3. Okay, well, here we go. Let's go back to the graph and look at f of negative 3. Looks like f of negative 3 is 0. So we're going to call this 2 plus 0, which is 2. So g prime of negative 3 equals 2. Now we're done with part A. Let's go to part B. On part B, we're asked to find where the function g of x has an absolute maximum on the interval from negative 4 to 3. So first of all, we have to remember a couple things. We have to remember that whenever we're looking for an absolute maximum, we're dealing with a closed interval. So we're going to need to find the value of g of negative 4 and the value of g of 3, the value of g of x at the endpoints of the interval. Then we also need to look at any critical numbers in between. In other words, we need to find places where g prime of x is 0 or where g prime of x is undefined. So let's go to work. G prime of x, we said, was really 2 plus f of x. So when does 2 plus f of x equal 0? Okay. We're going to come up to that one in a minute. And when is this undefined? Well, never. F is defined everywhere in this interval, so 2 plus F will be defined everywhere, or 2 plus F will be defined everywhere in this interval as well. Now, back to finding when G prime is 0. If 2 plus F is 0, that means we're looking to see when F of X is negative 2. So now let's come up here and look at the graph, and let's see. When does F of X equal negative 2? Well, let's see if we could figure this out. We've got a line segment. Our line segment goes from 0, 3 to 3, negative 3. So it looks like we could say that the equation of that line is y minus 3 equals, we'll find the slope in a second, times the quantity x minus 0. Okay, we're using the coordinates up here, 0, 3 for our line. And now, see the slope, we're going down 6 and right 3, so call that slope negative 2. So now, let's see here. We have y minus 3 equals negative 2x. Y equals negative 2x plus 3. That's the equation of our line. Now let's see when this equals negative 2. So we'll replace y with negative 2. Subtract 3 from both sides. Negative 5 equals negative 2x. Divide by negative 2. Negative over negative makes positive. X is 5 halves. So we have a critical number when x equals 5 halves, or when x equals 2.5. So we need to evaluate G whenever x is 2.5 also, because we find absolute extrema by evaluating the function at its endpoints and at any critical numbers in between, and looking for the highest or lowest value accordingly. So now let's find G of negative 4, G of 3, and G of 2.5. G of negative 4, well, that's going to be, let's see what we can do here. Let's look at the graph. Let's paste another picture of the graph here so we can write on it. So now the area of each region is listed on our diagram. Remember, for integrating from 0 to negative 4, the integral here in the third quadrant is going to be a negative value, and the integral in this fourth quadrant will be a positive value. So G of negative 4 is going to be negative 9/4 plus 1/4, which will be negative 8/4 or pi, or negative 2 pi. G of 3, well, that's going to be this area in the first quadrant, 2.25, plus the area in the fourth quadrant, which will be a negative integral. It's going to make 0. And now G of 2.5, we need to draw a different little triangle here. See, the base is 1. Let me think about this for a minute. The height would be, okay, the base would be 1, the height would be 2. So this area, this integral will be negative 1. So it's 2.5 plus negative 1 is going to be, so 2.25 minus 1 is going to be 1.25. We're looking for the absolute maximum. So it looks like the absolute maximum occurs at x is 5 halves, or 2.5. If they asked what the absolute max is, we'd say the absolute max is 1.25. Let's read the question. Find the values of x. So all we have to say is G has an absolute max at x equals 2.5. And we're supposed to justify this. Well, because we evaluated g of x at the endpoints and at the critical number. And we found that the maximum value was at x equals 2.5. There are other ways you can explain this using the graph. So if you want to discuss this, come on in and we'll discuss it in person. Thanks for watching the video.